2022, Liu and Xiao, 2022, have been proposed to improve the effectiveness of supervised dense retrieval models. On the other hand, zero-shot dense retrieval still remains difficult. Many recent works consider the alternative transfer learning setup, where the dense retrievers are trained on a high-resource dataset and then evaluated on queries from new tasks. The Ms. Marco collection, Bajaj et al., 2016, a massive judged dataset with a large number of judged query document pairs, is arguably the most commonly used. As argued by Issac-Ard et al., 2021, in practice, however, the existence of such a large dataset cannot always be assumed. Even Ms. Marco restricts commercial use and cannot be adopted in a variety of real-world search scenarios. In this paper, we aim to build effective fully zero-shot dense retrieval systems that require no relevance supervision, work out of box and generalize across tasks. As supervision is not available, we start by examining self-supervised representation learning methods. Modern deep learning enables two distinct learning algorithms. At the token level, generative large language models, LLM, pre-trained on large corpus have demonstrated strong natural language understanding, NLU, and generation, NLG, capabilities. Brown et al., 2020, Chen et al., 2021, Ray et al., 2021, Hoffman et al., 2022, Thopalan et al., 2022, Chowdhury et al., 2022. At the document level, text, chunk, encoders pre-trained with contrastive objectives learn to encode document-document similarity into inner product, Issac-Ard et al., 2021, Gao and Callan, 2022. On top of these, one extra insight into LLM is borrowed. The LLMs further trained to follow instructions can zero-shot generalize to diverse unseen instructions. Wang et al., 2022, San et al., 2022, Min et al., 2022, Wei et al., 2022. Wang et al., 2022, show that with a small amount of data, GPT-3, Brown et al., 2020.
I want to take a look, that's what you want. So they call ChatGPT, that's what they are doing. And then we have Contriver. Contriver. So we have instruction. We have query. Alright, so he's saying the prompt is broken into two sections. Instruction and query, and then we have generated document, and then we have real document. Where is the real document, by the way? So it's using ChatGPT, GPT-3. So they are comparing two models. One is going through ChatGPT, and the other model is going through the other one, like just a ranking algorithm or retrieval process. document similarity test. So we will have a similar to real document. It may be bullshit, hallucinated, but it is close to a real document. So we have an embedding of whole corpus. The most similar real documents are shown. On 11 query sets, that's nothing. This is just experimental study. Okay, first of all, no. It's not just, they have an idea, they have an invention in a sense, but I don't know how foundational it's like this invention, right? What they're saying, alright, we have this method and the new method that we suggest, and we are showing the comparison. So it's just talking about how they set up their engineering thing. It's nothing like proving a theorem. They're saying, all right, we did this to make this system or setup. They are not saying we did like run the best optimization algorithm. We improved an optimization. Fuck that. So now instead of here, they have like query document. A whole document is embedded, and they have like an inner product. So inner product is the similarity metric. Similarity metric. So there is no relevance to it. Okay, then it says the difficulty of zero-shot dense retrieval lies precisely in equation 1, which is the inner product, similarity, learning of two embedding functions, encoder of Q and encoder of D. We need to learn those two, document respectively, into the same embedding space. So both of them should go to the same space because we want to do their inner product. Yes, exactly. Like a fucking document can be so long. How do you encode it? So with height, you don't need to do the embedding. If I learn the embedding functions. So we have document similarity instead of document query similarities. See? Oh. Interesting actually. So instead of having, like both of the documents are from the same space, and then you can say, all right, I only need to learn encoder for the document instead of one encoder for query and encoder. And then it says, I think it gets calls from GPT for each query. So actually it is being done by GPT. All those embeddings of query is being done in a sense by GPT. We get a document, we embed that, and we embed another one which is for the real document. So it's like a hack or a bypass. What is detour? V of D. What is V of D? But D1 to D is word. For each D document we have a vector. But what is D1 to DL? Oh, they are query sets and they are document sets. Okay, G gives us a document for, it gets a query and instruction as was shown in the, or we can say a prompt, and gives us a like a made up document, which is close to reality but may not be true because it is hallucinated. Which instruct LM means chat GPT, like that's it. And the idea is super simple, and they are just comparing the results and see how which one. Like the juice of the paper is in the experiment, not in the. Okay, the idea is also interesting, but it's not a very challenging mathematical problem. What is V? V was the vector for Q. G was the hallucinated document. F of the G was vector of the. Why is the expectation of these two equal? query is not ambiguous. Oh, okay, so they are talking about it too. The study of ambiguous query and diversity is left to future work, which is what we are, but so the vector we assign to Q is, what are I and J, by the way? We generate n document from ChatGPT, we get their embedding, we get their average. They also say the query itself can be a document. We get their its f as well. So then they just, that was the math, and that was what they did, all the math. Honestly, I want to do a paper like this. I think going to theory is just meaningless. You have no experiment. Build your theory based on what? Because I have to make a call. Let's get back to our paper. Experiment. Experiment. What the fuck is that? Experiment. Why? Alright. Setup, implementation. We implement hide using instruct GPT-3. Oh, so it's not Chat GPT-3. It is GPT. It's something. So they have two papers, two models, and they're building something. It's just they're building something. Okay, so they have access to OpenAI Playground. That's great. I think it's my mustache. For open-ended generations, so they are just running an experiment. It's just interesting, and they are publishing. You know what reminds me of? Like, you go on YouTube and this like influencer says, I did this for 30 days and this is what happened. That's it. We should play around with it. It is, I'm not saying this research, it is simple, but it is very important to get, it helps us understand fucking GPTs better, and it helps us come up with better retrieval models. It doesn't need to be heavily mathematical. I repeat it every time because I just want to go inside, like my brain. It goes all the way my spine down. So they're just using different models from different thing, and they're just building things. Alright, so now they're showing how they did it, like how good they worked, how well they worked. It's just being an inventor that's amazing. Quite outperforms. And they have like different things, like low resource retrieval. And they have multilingual retrieval analysis. Then effect of different generative models. Like it is like a side moves, right? You have a main idea, and then you kind of perturb the idea and see how it works to get better understanding. Conclusion, done. That's it. That's called an experimental work. I love it. I want to do an experimental work. Honestly, okay, this is one thing I want to share with you. So I talked a lot about, like, one video I talked about, like, choosing my major, and 10 years ago, I think the title was 10 years ago, right? So I think this is my conclusion. I don't like personal taste, right? I don't like forcing mathematics on everything. Yes, it is very beautiful. Sometimes mathematics works, and sometimes it works, and dude, it's just a repetition. You want feedback on repetition.
At the end of the paper, we encourage the
So at the end of the fucking paper and my life as a PhD student, I'm telling you this: I rather study 2 hours or like pure mathematics in a day, and then 6 hours I want to be an engineer. I don't want to just use mathematics. Is something I want to be good at. I hate trying to solve everything with mathematics. That's stupid. Mathematics is beautiful, everything, but it's not everything. Done. And I don't like solving. If it doesn't come up naturally, I don't want to force. Yeah, maybe I give it a chance, but it is not necessary. I think from an engineering perspective, you need to make the final product work, and I love that. Why not? It's cool. You become somebody who is. I think the truth in engineering is not trying to build up a mathematical model. The truth in engineering is try to find out what the problem is and solve it with whatever you have. And sometimes mathematics can be useful. Done. Also, I like to, as my hobby, go and study mathematics, like know what's up there. The idea of you have this commitment to mix mathematics with engineering, you have to do that. It's so forced.
At the end of the paper, we encourage the readers to take a moment and reflect on the Hyde model.
Okay, I think actually that's a big achievement for me. I was a person who believed in that, and now I say, fuck this. That was like after years. Actually, it's not that important.
Compare it to some of the other recently seen retrievers or re-ranker.
Let's appreciate
These other
mathematics
models
for what it is, and let's appreciate engineering for what it is.
Differ in their architecture, training method, and or task, but probably all of them involve modeling relevance scores between a pair of query and document. Dense retrievers consider vector similarities while self-attentive re-rankers regression scores. In comparison, the concept of relevance in Hyde is captured by an NLG model and the language generation process. We demonstrate in many cases, Hyde can be as effective as dense retrievers that learn to model numerical relevance scores. So, is numerical relevance just a statistical artifact of language understanding?
And it is a research in engineering. Also, we have research in medical science. They are not forced to do everything with. Science is about experience.
More works need to be done to get answers.
At least 50% of the time,
with
if
this
not
paper,
80.
We just want to raise these questions. Concretely in this paper, we introduce a new paradigm of interactions between LLM and dense encoder/retriever. We demonstrate, part of, relevance modeling and instruction understanding can be delegated to the more powerful and flexible LLM.
Not even the mathematical problem looks beautiful when we force this.
We are excited
bullshit.
to see how this can be generalized further to more
It's not a beauty,
sophisticated
even when
tasks
you
like
solve it, you
multi-hop
don't
retrieval
think,
/QA
you
and
solve the math
conversational
problem.
search.
And when you
Hyde
solve
is
it,
also
nobody
of
can use it
practical
in
use, though not
engineering.
necessarily over the entire lifespan of
You
a
solve
search
no
system.
problem. You created a problem
At the very
that
beginning
the
of the
solution
life
is not
of the search
valuable for
system,
none of
serving queries using
mathematicians
Hyde offers
and
performance comparable to a fine-tuned model, which no other relevance-free model can offer.
engineers.
As the search log
Maybe,
grows,
I don't know, maybe a lot
supervised
of
dense
these works
retriever
also
can be
like in
gradually
100
rolled
years
out.
or in 50 years they
As the
become
dense
useful. But
retriever
I wanna,
grows stronger,
okay, also me,
more
for me,
queries
these
will
are
be
just
rooted to
personal
it,
taste.
with only
I wanna
less
see the
common and
result of
emerging
my
ones
work
going
right
to
now.
Hyde backend.
I don't like to do it for future generation. I wanna do it for my generation. Done. Simple paper, I loved it. Thank you, I wanna. What was the name? Height. Zero shot height. So let me stop it here, and we are going to finish that fucking slide later.